Hello, everybody. Another very important prerequisite leading into the 6-point parallelogram proofs. This one's very important. I can prove alternate interior angles are congruent given a parallelogram by carving out the parallel lines and the transversal. Let's get to it. It's giving you that this is a parallelogram, and we know that a parallelogram has parallel lines, and we know that parallel lines form congruent alternate interior angles. So the reason I put this in here is just to identify ultimately what triangles I'd be proving. This is just a mini proof. I'm not actually proving the triangles, but these are the triangles that I'm looking at. Once you see a parallelogram, expect to have to prove alternate interior angles are congruent. So you're looking for a diagonal or a transversal within this problem, and I see it right here. So I need to carve out my angles formed by my transversal and my parallel lines. Boom, boom. That's it. Those are my congruent alternate interior angles. To make it simple, I'm going to write a 1 and a 2. I'll show you how to put it into the proof, although mostly I'm just going to mark it. I'll maybe write 2 of them out. Statements, reasons. Hope is a parallelogram. Given angle 1 is congruent to angle 2. Now, this is a little bit more than usual. I'm actually really combining 2 steps into 1 step here, which you can do, but the reason is a bit long. Because we're given that it's a parallelogram, my reason has to start with a parallelogram has. A parallelogram has parallel lines cut by a transversal, which form congruent alternate interior angles. So it's your parallel lines cut by a transversal create congruent alternate interior angles with just a parallelogram has in front. Because we're not stating that the lines are parallel, we have to state that a parallelogram has and go from there. So it's a bit long. You're going to have to do this. Once you have a parallelogram, you're going to look for alternate interior angles to find them. Follow your transversal, create your Z, and your angles are formed by that Z. State the angles are congruent. A parallelogram has parallel lines cut by a transversal, which form congruent alternate interior angles. I'm given that it's a parallelogram. I'm looking for a transversal or a diagonal. I see it right here. And let's see, I want to prove this triangle and this triangle. So here is my diagonal. There is my Z. There are my alternate interior angles. I'm not going to write them all out. This can apply to similar as well. HAT, HAT, AEH. It's giving me that it's a parallelogram. I'm looking for a diagonal or a transversal. There it is. There's my Z. There are my alternate interior angles. Number 4, there's actually 2 transversals, AEH. So these are my 2 triangles. I see a diagonal here. So when I carve that one out, I have this and this, 1 and 2. And I have another right here. So when I carve that out, I get these 2. So I have my green Z and I have my black Z. and I'll call this 3 and 4. And one more time, how do I put this into the proof? Well, statements, reasons, A, B, C, D is a parallelogram given. I can say that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. And the reason, again, being how I'm given that it's a parallelogram, my reason has to start with a parallelogram has parallel lines cut by a transversal which create congruent alternate interior angles. I can almost guarantee you that this will be a step in every single problem. So it's very important that you're able to do it. Again, if I give you a parallelogram, you're going to look for these alternate interior angles. AEG, this one, and this one. So I'm looking for my transversal or diagonal. There it is. Carve it out. Those angles are congruent. I've got another transversal here. Carve it out. Those are alternate interior angles that are congruent. Got to be able to do this if you're going to move forward. Practice it. Do what you need to do. Once you get it, it's not bad. But if you can't do this, you're not going to be able to do the 6-point proofs. Again, if you're given a parallelogram or you prove a parallelogram, once you have it's a parallelogram, you need to expect to need to prove alternate interior angles. Look for your diagonal or transversal. Carve it out with a Z, and then your alternate interior angles are inside the corners of those Z's. There could be one transversal. There could be more than one. If there's more than one, you could have more than one pair. The more pairs you have, the better. That's it. Practice. Goodbye.